was weird. Okay. Anyways, starting at the top, this is lesson 3-1 and 3-2. Miss Buesa, when she wrote these notes, she combined them because 3-1 and 3-2 were so similar, they almost overlap, so she combined it into one lesson. What we're going to do is just cover the first 2 pages of this lesson today, and then on Monday, we'll cover the next 2 pages. You will have a homework assignment today, homework 3-1, and then on Monday, you'll have homework 3-2. I know last chapter there wasn't a lot of like solving in terms of math, and people requested that we have more solving. Obviously, this chapter does have more solving in terms of math, but it also has vocabulary and concepts as well. This lesson specifically, 3-1, is more based on concepts, but I promise this chapter does have more solving than the last one. This chart right here, you might see that there's parallel and skew. I know parallel, I'm sure you're very familiar with that word. Parallel lines as you know, look like this. There are 2 lines that go on forever and ever. They never intersect. They're going in the same direction forever and ever. There is a symbol for parallel that you need to be familiar with. If it has like this little arrow on the line and it matches the little arrow on the other line, this signifies that this line is parallel to this one. Parallel lines never intersect. They are coplanar, meaning they're on the same plane. And they go in the same direction. Okay, skew lines is a word that you may not have heard before, skew lines. And skew lines are very hard to draw on paper. Skew, when I think of skew, it's kind of like out of the way or in the wrong direction, like skew. What it means in geometry is, okay, skew lines never intersect just like parallel lines do, but they're not always going in the same direction. So like they're on different planes. So like you might have one line going this way, and then you have another line going this way. They aren't going the same direction, but because they're on different planes, they never intersect. That's what skew lines are. You could even have this like angled, and again, it would never really intersect with this line, and that's what skew lines are. So by definition, they are non-coplanar. They aren't on the same plane. They don't, oh, are you kidding? Oh, it's back on? Okay, good. They don't intersect. And then, again, it's hard to draw this, but if you think of a visual, it would be like a highway overpass. The 2 highways are crossing, but one's not. You aren't running into the cars on the lower part. So a highway overpass is an example of what skew lines might look like. Okay, and now we're going to look at these words in regards to 3-dimensional figures. Here is a rectangular prism. If we were to identify parallel lines in this shape, remember a line doesn't have to be drawn, but through any 2 points there is a line. So if I was to look for the line parallel to line AB, that would be line DC. So writing that, I could say that line AB, and there is a symbol for parallel, so you don't have to write out parallel every single time. Parallel looks like this. It's like 2 lines like that. AB is parallel to line DC. So that little symbol right there means parallel. I should be using pencil. Another example of parallel lines here might be, again, might be this line right here through CH and the line through BG. These 2 lines are parallel, so CH is parallel to BG. Okay, so what would skew lines look like on this three-dimensional figure? So you're looking for two lines that don't intersect but aren't on the same plane. So maybe AD and CH. And we could name a whole bunch of skew lines. We're not going to name them all. AD and CH are skew lines. Obviously, there's way more examples, but if we were to write everything, it would just get too crowded. Yes?
Would those like eventually intersect though?
No, because if you see it as like a, let me see if I ever, oh, if I had a rectangular, like this line, if it went up forever and ever, it wouldn't intersect with this line over here. Like it just would never intersect because they're on different planes.
Oh.
Yeah. Then for planes, there is a such thing as parallel planes. And parallel planes are planes that never intersect. And we'll look at an example on this one right here. She didn't have anything written in here. We're not using this box. And we're not using this box. There's really no such thing as skew planes, because skew planes would always intersect at some point. Okay, so parallel planes on this rectangular prism, they're planes that are parallel. So the top here is parallel to the bottom. And obviously there's more sets of parallel planes in this figure, but just so you get the concept. So plane, and when you name a plane, you only name it by 3 points. So we'll just say plane ABC and plane GHE are parallel. Okay, now we're going to look at some questions in regards to this. We're going to answer these questions, and we have this example over here. I'm using a pencil because I'm going to erase marks as I go. Lines parallel to AB. So we look at this figure, identify where line AB would be. Lines parallel to that, it would be this line, the line in back, and then this one. So for most of these, we'll have multiple answers. So line parallel to AB would be line DC. This one, EF, and the back line right here, GH. Okay, next one. Lines perpendicular to line BF, so this line right here. Perpendicular would mean it intersects and creates a 90-degree angle. Since this is a rectangular prism, we have lots of 90-degree angles here. But BC right here. Also, FG would be perpendicular. A, B, and anything else? Oh yeah, EF. Okay, and erasing. Next one, lines skew to CD and containing point E. So let me find CD. CD is this back line right here. I need a line skew to that includes point E. It would be right here. Or it could be right there. Let's see. What was that? EH. I just wrote on the letter I need. So that's EH. Also, EA would be skewed to CD as well. EF wouldn't be skewed because it would actually be parallel to CD. And then number 4, planes perpendicular to ABE we didn't talk about perpendicular planes, but I think you can figure this out just based on the definition. A lot of times, textbooks, resources, they don't know where to stop with the information. Something that's kind of interesting about math and science, actually any subject, is there's always more information to learn, and where do you stop? The answer is you don't. Like, there's an infinite amount of information. So as far as the geometry curriculum, there's an infinite amount of information we can cover. So be prepared for things that you may not have seen, but a lot of times you can tie together the vocabulary to figure it out. So planes perpendicular to ABE. So here's ABE, it's this front plane right here. Planes perpendicular to that would be planes that intersect at a 90-degree angle. There's multiple planes here. So this one over here, remember to name the planes by 3 points, so CBG, GFE, ADE, and again, I'm just choosing 3 random points on the DAB. Okay, so again, there's no one specific way to name those planes. I was just using 3 points. It doesn't matter which order. Then number 5, planes parallel to plane ABC. So ABC is talking about the top plane right here. Plane parallel to that would be the bottom plane. So plane EHG. Again, however you want to name that with 3 points from the bottom, it's up to you. Okay, next part of the lesson. Next, angle pairs formed by a transversal. So again, like I mentioned on the board, we're going to be dealing with parallel lines and a transversal. Transversal is a line that cuts those 2 lines. Now, parallel lines is where we're headed to. If we look over here for Monday, everything is going to be parallel, but they teach you the vocabulary with the lines not parallel, but it's the same idea, and we're headed toward this. So this line right here is a transversal, and it's very importante. Muy importante. Anyways. So the first term, a transversal, and the formal definition is a line that intersects 2 coplanar lines at 2 different points. So it intersects 2 coplanar lines at 2 different points. Over here, we have an example, 2 coplanar lines, and then we have the transversal right here. Okay, so with this setup, these angles have relationships, and based on those relationships, they're given names. The first name is corresponding angles. Corresponding angles, I feel like those are the most popular. They just come up the most. So, most popular word. Corresponding angles, they look like this. So, we have parallel lines and a transversal. Actually, I'm going to draw 4 of these. So, draw 4 of them small. Why the heck did I draw 4? Because corresponding angles would be like this angle and this angle. Right here. Those are corresponding. It would be this angle and this angle. It would also be this one and this one. And this one and this one. Okay, are you seeing the pattern? It's on the same side and it's in that same corner right there. Lie on the same side of the transversal, on the same side of the lines. And that's where the definition stops. But these are corresponding angles right here. Corresponding angles, when you have parallel lines, are equal in measure, and that's where we're headed later. But those are corresponding. I think we might do a Kahoot in class today to practice these, because they just need to be practiced. Okay. Next, blank are non-adjacent angles that lie on opposite sides of the transversal inside the lines. I know that definition doesn't help you much. Alternate interior angles. Other than corresponding, you can use this to figure out what they're talking about. So we're going to draw two of these this time. Alternate mean alternate sides of the transversal, and interior meaning the inside of the parallel lines. So alternate interior would be this angle and this angle are alternate interior. So this one and this one. So alternate sides of the transversal inside the parallel lines. And then this one, this angle and this angle are alternate interior as well. Alternate interior angles when you have parallel lines are equal in measure, and that's where we're headed with this. Okay, the next one, you can use the words to remember which pair it is. Alternate exterior. So again, we're going to draw two of these. Okay, alternate exterior, alternate sides of the transversal, and exterior meaning outside the parallel line. So we got this angle and this angle are alternate exterior. And then over here, this angle and this angle are alternate exterior. And alternate exterior also have the same measure. And last but not least, consecutive interior angles. Consecutive interior angles. Okay, consecutive means like right next to each other or in order, and then interior is inside the parallel line. So consecutive interior are actually right here. So these two angles would be consecutive interior. And then on the other side, these two angles would be consecutive interior. Actually, I know it's not part of this lesson, but just so that you can use this as a reference, corresponding angles are congruent. They're going to be the same measure. Alternate interior angles are also congruent. They'll be the same measure. Alternate exterior angles are equal as well. And then consecutive interior are not equal. They equal 180 or add to 180. So these two added together would be 180 degrees. Okay, now we're going to use these words and practice identifying angle pairs. Okay, so in this example here, we have our two lines. In this example, the lines aren't parallel, but you get the gist. And then here's the transversal right here, so it's kind of sideways from what we were just looking at. But we're smart, we can still do it. Okay, so it says angle 1 and angle 7. They are alternate sides of the transversal. They're on the exterior. So 1 and 7 are alternate exterior angles. Then 8 and 3. So here's our transversal. 8 and 3, they are consecutive interior angles. Have you guys seen this before? Anybody seen this before?
Can
No?
you zoom in a little bit?
Yeah, sure. Yeah, I think it comes up in 8th grade math, but all of you skipped 8th grade math. 6 and 5. Now these two it doesn't match any of these relationships. 6 and 5 are a linear pair. Then 4 and 2, those are vertical angles. And 8 and 2, they are alternate interior angles. And then F, 7 and 3. Anybody know what those are? Corresponding, yay! Awesome. Corresponding angles. Okay, that's all we're covering today. Tomorrow we're gonna practice this. I do want you to look. I'm gonna look at the homework with you that's on Schoology.